DevOps engineer stuff, but
Alex still faces the same problem as they faced before. The software is still being tossed over the wall. So Alex starting to realize that just having a title of a DevOps engineer is not enough, and goes and start learning more about what practice of DevOps is all about. We have an example here from the source of all truths, obviously the Wikipedia. But Alex not just discovers the Wikipedia article on DevOps describing what it is, but also some of the best books on the subject, such as the Phoenix Project, the DevOps Handbook, and the Accelerate book. Alex discovers that DevOps is not a title, it's not a job, it's not a department within a company, but it's a common set of goals and common culture between the three key constituents, and there are actually many more constituents, as we'll learn later in the presentation, that are responsible for delivering software.
Yeah, and one of the resources that Alex go through is the State of DevOps report, and this is by the Accelerate. The book is actually the science behind the report, and the report itself, year after year, evaluates organizations in their DevOps journey. And comparing their organization to other organizations, Alex realizes that they are what it's called low performance. You can see here they release very rarely, and the quality of their releases are not very good. They have a very hard time restoring service after failure, etc., etc. And another thing that Alex realizes is that while they are those low performance, there are a lot of elite performance, and their number of the elite performance actually tripled only in 1 year, from 7% in 2018 to 20% in 2019.
That's a pretty impressive change.
Yeah, and then Alex wonders why.
Why? Well, the story of why is pretty simple. The primary goal of each organization is to deliver services or products to who? To their end users, right? And those users, what do they want? Obviously, they want new features. They want new capabilities. We live in a very competitive market. You can also ask, when do they want them, right? Well, they want them now, or in some cases yesterday. We live in the world where software services offered by organizations are incredibly competitive. So it's only natural that through evolutionary pressure, the groups are starting to split. Folks are moving up to become elite, and they're trying to consolidate the market and being successful in the market. And those that don't adopt some of those practices that you can read in the State of the DevOps report are starting to dial back and lose ground compared to some of the best shops in the business.
And Alex, realizing all that, managed to get themselves into some very important meetings. And the bosses in those important meetings constantly push to release faster because they realize, as Leonid just mentioned, that it is an evolutionary pressure, and if they want to stay in business, they need to release faster. And then ideas tossed up, stuff like, let's hire more DevOps engineers. DevOps help us release faster. We need more of those. Or let's fire those who are the bottleneck according to what we learned. And that would usually be maybe a QA, testers, or security. If we won't do those checks, we will release faster.
That's
right?
one way of optimizing bottlenecks.
Of course. So all those ideas, and then Alex, as someone who is knowledgeable what DevOps is, actually suggesting implementing DevOps as it should be. And you know how this meme ends. This doesn't come through very, very successfully.
And that's where Alex realizes that organizationally wide, the key decision makers are sitting up there in the org chart, like up there. And Alex finds themselves up there in the org chart. And without knowing and being able to influence those decision makers correctly, none of those bottoms-up transformations will be successful.
And then Alex find the way. Let's talk about that. My name is Baruch Sadogursky. I'm the Chief Sticker Officer at JFrog. Not being able to be in physical DevOps days with you and give you some stickers, we're doing this live and me acting as a head of DevOps advocacy in JFrog. The most important piece on this slide is my Twitter at jbaruch. Let's connect then.
And I'm Leonid Igolnik. Professionally, I'm an engineering executive who have helped a number of teams go through this DevOps journey and have been fortunate enough to be at some successful SaaS companies such as Taleo, most recently SignalFX. I'm at L Igolnik on Twitter. And if you have any questions after this presentation, feel free to hit me up.
And this is the most important slide of this presentation. If you go to jeffrog.com/show notes, you will find a page dedicated to this session on which you will find the slides, the video, all the links, everything that we already spoke about and will speak about, a place to comment, for rating, and a small raffle to thank you for being here. Actually, maybe not so small. In order for you to always remember where this page is, I'm going to put it right here in the bottom of the screen. So yeah. So you will be able to go there whenever you like. Also, our Twitter handles are there as well, and the Twitter handle of DevOpsDays Kyiv. So with that, let's learn how to change our organizations.
And since Baruch and I were born and grew up in a country that was founded on the principles of learning, and learning more, before we get into the mechanics of how to help you transform the organization bottoms up, we wanted to highlight some of the key resources and some of the books that we consider the go-to resources when it comes to the theory and fundamentals of DevOps.
Yeah, so those are the same books that Alex read before they became an expert in what DevOps is, and we recommend you to do the same journey. It's obviously the Phoenix Project and the Unicorn Project, which are novels about DevOps, the DevOps Handbook, which is really a very hands-on on what DevOps is, amazing book, War, Peace, and IT, which explains in the lingo of managers why DevOps is important, site reliability engineering, what the real DevOps engineers, or as they should be called, site or service reliability engineers should do, and also a Liquid Software book, which I have the honor to co-author with two JFrog co-founders, and this is about how to make your software flow from the development all the way to production, also very, very relevant to DevOps.
And there are many, many other resources. There are some great podcasts. Baruch is hosting DevOps Speakeasy online. We strongly recommend DevOpsish as a podcast, as well as other conferences, DevOps days that are recorded on the internet, and you can find the talks on YouTube, as well as one of my favorite tools, the Technology Radar that a company by the name of ThoughtWorks puts together, where they evaluate techniques, tools, practices, and languages, and make recommendations which ones you should be considering, which ones are ready for adoption, and which ones you should be thinking about discontinuing the use. It's a great resource that I update every other 1 or 2 quarters. So now that you're completely ready and fully equipped with the theoretical knowledge, you are ready to charge and run your transformation, right?
And then you go by your boss, and this is what you get.
Nope. Unfortunately, more often than not, a lot of the bottoms-up transformations start like that.
And this is something that you really need to be prepared for. You will need to be prepared for a lot of people to just say no, either because they're super busy. Sometimes they will say yes and promise you things, maybe even honestly, but then just got distracted by stuff.
Some of the folks will be all talk but no work. They will tell you, yes, let's do that. But they have conflicting priorities or other things that they're trying to optimize for. So you have to be aware of that. Quite honestly, transforming an existing organization that has been functioning for a while is hard. You need enough, like in chemistry, you need to input enough activation energy to get the reaction rolling and getting the flywheel spinning, and then it gets much easier. So that initial transformation is very difficult.
I guess what we're trying to say that you will want to give up because it's hard, it's slow, and you might not get enough support that you really wish. But as the great Winston Churchill said,
never give in. Never, never, never.
Having said that, it's also important, while you don't give in, you also don't try to go and boil the ocean. Most successful bottoms-up transformations we have seen start with a smaller team and not trying to change the entire organization at once.
I think it's time to lay out our suggested strategy to take over the world.
And that strategy comes from this book called Influence Without Authority that lays out a 6-step model that we will go through step by step that will help you understand some of the considerations you need to think about as you try to influence an organization without having that authority to impose your will upon it. And the first step in the model is very simple and maybe not very intuitive. You have to assume that everybody in the organization can be your potential ally, and you have to go and figure out how to look for them.
So, I mean, I get it where it all comes from, but even me being super friendly, I still doubtful that I can consider everybody my friends and allies.
Well, let's talk about some of the places where you can go and find those allies. Most useful technique is to go find some kind of forward-looking team, a team that maybe is a bit more progressive in their thinking about how they want to operate, and maybe do the transformation there so the rest of the organization can see that transformation success by example. So partnering or discovering those forward-looking teams is incredibly important. Secondly, or second source of those early allies to look for are some visible projects that have a lot of attention to them, and especially if they're coupled with a highly progressive team, can demonstrate not only that the success of transformation can be done, but also how it can drive a success of a visible project. Now, not every team is like that, so you have to be aware of self-promoting teams that will cheat or will try to partner up with you for the wrong reason, so you have to be careful about diagnosing that. But most important advice we can give you there is talk to the people, the water cooler talk, understanding what folks are up to and what motivates them, what's important to them in their daily professional lives can be a great source of discovering the right ally to start your transformation.
And when you speak with your allies, it's very, very important to remember what motivates them, what drives them. One of the obvious and important drives is obviously their own success and their own careers, and this is fine if you manage to do what you plan to do with the help with the people. You all can benefit from it, and there is nothing wrong with that. We need to remember what drives people, and it's not always obvious. We might think that people are pretty straightforward and driven by carrot and stick, but actually it's much more complicated. A great source for a little bit of enlightenment of that is a drive book by Daniel Pink, in which we can find 3 very, very important factors for drive: the autonomy, mastery, and purpose. We're going to talk about how to employ those factors to influence people, and we will give you practical examples of which each one actually mean for different people and allies that you work with. You also need to remember that people are irrational and they don't behave like computers, like what you, if you are an engineer, is used to when you apply certain things and you expect certain reactions. It works a little bit like that with people because people are predictable, but they are predictably irrational. There is a lot of research in the last 50 years into behavior of people, especially behavioral economics, because this is where the money is. But as a side effect of those research, there are a lot of great resources on how you can sway people in your way and how you can find those allies and actually make them do what needs to be done, not only for your sake, but for their sake as well. Remember, what drives them is what they can become and what they leave behind them.
It's also important not to forget that the folks that you're going to have to influence in the position of authority may be motivated by creating a permanent legacy for themselves. So that's an important consideration, an important driver that may be considered irrational, but can drive more transformations that you can imagine.
And just to kind of give you a pragmatic example of what influences people that you are going to try and sway your way, for example, how am I measured? We're going to talk about how different measurements or different goals can tank your entire partnership with a person. What my boss expects from me, if whoever you speak with, their boss is opposed to your idea, probably you will have harder time to convince them. Will I enjoy doing that? Well, this is easy. How fun organizational transformation is, this is how you all gonna enjoy it. where my career stands. We spoke about that, the resume-driven development, and also generally, am I in a trajectory that I want to shake trees or I want to lay low in this part of my career? How the people of whoever you work with how the peers of the people whoever you work with will react to that. Will they cheer for your success, or they will be skeptical about how busy the other person is? Do they even have the bandwidth to help you? Organizational culture, either the organization welcomes change or resists change, the background and the education of the other person, and what happens outside work if don't they even have a mental bandwidth to deal with more that you put on their plate, or they have enough somewhere else.
So that brings us to our next step of the model. Once you have identified the right ally, that's also important to understand why you're trying to push that transformation. We talked about the evolutionary pressure of doing the right thing for the business, but there's also doing the right thing for the team. So evolutionary pressure is a good factor. And also creating an environment where you work that doesn't look like this, right? An environment of the tools, the techniques, and the environment that sets you up for success rather than constant fight for survival as an organization could be a really, really important factor. And again, let's not forget that if you do this successfully in this day and age, we're still early for a lot of organizations on this DevOps journey. Enhancing your resume, setting yourself up for subsequent opportunity is also a very important achievement that you can put, and that could be absolutely valid motivation. We don't want to spend more time on that subject because everybody's motivations are different and they're driven by different folks, but we'll shift to the next area. Remember those teams that you have to ally with and partner with. Let's talk about diagnosing their world to understand what may be driving them rationally or irrationally, so you can create that partnership more successfully.
For diagnosing the world of other people, we need to look for data because, we love data. This is something very easy to argument with. And when we come in and say, you know what, you are now in X and we want you to get to Y, showing the numbers for both of them is really beneficial. And with DevOps transformation, it's very easy because the metrics are well known. This is, again, we are looking at the Accelerate State of DevOps report and Accelerate book, and we see 4 key metrics for DevOps performance. The lead time from development to deployment, the change failure rate, the deployment frequency, and the time to restore service. Once we measure all those in our organization, and again, look at the Accelerate book for more details on how to measure it, then we can actually show to our allies, look, we are in trouble. We are the low performance. Now, let's make an effort to take us all the way to elite, because you remember, this is where our legacy is born. This is where our resumes are get pretty. This is we will feel accomplished. Right? So we want information on where we stand now in order to show what we can do for them.
So next, we're going to talk about where to find those things that may be motivating your potential allies, specifically on how they're being measured. A good place to look is goals or OKRs, if your organization has that practice, to understand what may be important to the team that you're trying to partner up. The other area to look at is their backlog. What are the high priority items that they have in Jira or whatever backlog management system you may be using? You can look at the presentations they have from offsites or presentations they may have given to their organization on what they're up to. That can serve a good clue for example, for finding a highly visible project. And lastly, but again, not the least important one, you have to go and socialize. The water cooler talk, talking about what's going on, what are the key items, what are the key priorities for the organization, can be an incredibly valuable source for that type of information.
And now let's go and try to analyze the world of other person. And when we are dealing with DevOps transformation, we need to interact with the entire organization, with everybody in, at least the developers, the operations people, the QA people, the product people, and the security people. So we will give you example of two of those cohorts. We're going to look at developers and operations and analyze what their world look like.
Let's start with developers. And let's talk about like typical driving example of an autonomy for a software engineer, right? A typical software engineer wants to have minimal number of obstacles of delivering the code that they just created to the production environment where that can provide some value to the customer of the software. So typically, not having a dependency on the system administration team or the ops team is a great example of increasing the autonomy of the developer team.
And following the trinity of drive, autonomy, mastery, and purpose, when we look at the mastery of developers, what developers excel at is writing code. And writing code for today's cloud-native, DevOps-enabled, fast-paced, big data world is very, very rewarding in terms of mastery. So when you speak with developers and you say, hey, you can create much better software if you only start looking at DevOps as a big picture, is very, very satisfying their mastery angle.
The next principle from the Drive book is purpose. And for developers, the purpose is pretty easy. It's great software available to customers to use, which means it only matters when it's in production, right? That's the primary drive, and that's an advantage of that's the drive that you can take when you're trying to motivate the developers through the purpose aspect of their aspiration.
Another aspect that you really, really need to consider is what the person that you're trying to influence fear of. You both first need to understand what their fears are, and then you need to address those fears and convince them that the transformation that you have planning and you want to bring them along will not cause what they fear the most. Now, when we're talking about developers, their fear of DevOps might come from the misunderstanding of what DevOps is. They might think that it actually means that they will now have to do not only their job, but also job of the ops people. Not only writing code, but also deploying it. Not only being there when the code is written, but also being there when the code is deployed, participating in on calls, and all this stuff. Being able to address this fear and explain why it's not bad that they will know some of the world of ops is your job as well.
So the next example we wanted to give you some concrete examples on is the operations team, right? And using the same factors of autonomy, mastery, and purpose, let's talk about autonomy. Like when it comes to the needs of their operations team, they need to be able to configure, scale, deploy, upgrade software, ideally independently of other teams, whether it's the testing team, for example, by having a test suite that allows them to validate that the software was deployed correctly, or the developer team without having to go for a developer trying to figure out what configuration parameters may need to be changed when you move from one data center to another.
Mastery, this is easy. All the DevOps toolchain is what Ops Mastery is. This is what SRE are doing. Infrastructure as code, Kubernetes, service meshes, all those wonderful technologies is the mastery of the new Ops people, the SRE.
The purpose for the ops team is pretty easy. The software should be always on, always available, and it's easy to measure. It's called an SLA. In addition to SLA, of course, there are service level objectives, the individual objectives for the servers, things like response times and whatnot. But primary purpose for any operations team is to have the software available reliably to the customers of the software.
And of course, the fear of the ops people is giving up control. While those pesky developers start to go and deploy stuff in production, everything will break, everything will be on fire, and the operations people, we will be there to blame. Obviously, it's your job to convince them that this is not the case. So those were the dev and the ops, but as I mentioned, there are many others. Do this exercise by yourself and try to model the world of the testers, the product, the security people, and see how they map to those 4 points. What you need to remember is that duck typing that you love so much in your code, Python and what's not, if it quacks like a duck and walks like a duck, it's a duck. Stereotyping when we come to people is much more dangerous. So do this experiment, but be prepared to be surprised.
So moving on through our model, we found the allies, we understand our motivations, we now understand the motivations of others. Let's talk about currencies that you can use or things that you can bring to the table in order to motivate them to go on this journey with you.
We're not talking about money, we are not talking about dollars. Instead, we are talking about currencies that you can use in this give and take of ideas and motivations. Inspiration related, something that you can give that will inspire other people. Task related, something that will help them fulfill their goals. Position related, something that will help them advance in their career. Relationship related, something that you do for other people as friends, or even person related. If you know something about the person in question, you can use this knowledge as a currency itself. And I'm not saying it in a bad way.
So the most important thing you can try to do is to create a symbiotic relationship, right? Where there's a mutually beneficial arrangement between the teams that are collaborating, and then there's the broader benefit for the entire company or the entire ecosystem of teams.
We'll give you one example of such currency, and that could be a hackathon. And hackathon is a wonderful currency because it serves in more than one facet of currency. For once, it's something that you do for other team. If, for example, during the hackathon, you manage to get some project that advances other people's causes, then this is a currency that you successfully traded. But also a hackathon, it's an inspiration-related currency because it shows people how to achieve a lot using those empowered teams that when everybody works together and help together getting the work done. This is microcosm of DevOps, and this is inspiration-related currency.
So the next step in the model is dealing with the relationships. Now you know your partners, you understand what motivates you, what motivates themselves. Now you have to ensure that your dealings with them don't end up like Alex ended up being thrown out of the window with a no as an immediate answer. This is a subject that we don't have time to cover deeply today, but there's a ton of useful and interesting literature, some of which was already mentioned in this talk. Predictably Irrational, Sway, Who's Got Your Back, Super Connector, Never Eat Alone. Some of the examples of the books you can go and read on the art and the science of establishing good relationships with your partners in crime. Moving on through the model, the next step and the most important step in that model that we've been preparing for is the influencing through give and take. And give and take quite often is known as quid pro quo and can have negative connotations. And yes, there are contexts where quid pro quo is absolutely negative or at times is even illegal. But you have to remember that most organizations are built on this give and take and quid pro quo. And what we're going to do next is give you some concrete examples of the type of exchange that you may be seeing. So the first and most important one is the alignment of interest. Remember those goals in the OKRs that you looked at to identify potential allies? That's the type of quid pro quo where multiple teams come together and they may be interested in the same outcome.
The second one is simply barter. You have some resource that you can spare, and bartering this resource with others people influence can help you advance your cause.
Last one is basic and most fundamental favor exchange that I'm sure you're familiar from your even personal lives. Sometimes giving somebody a favor is giving you some brownie points or some capital to go spend when you need their help to do something. So being proactive and giving favors and also being reactive and maybe collecting some of those favors is important. And favors can be you have access to a particular resource your team is not using that the other team can benefit, and you proactively, because you know what motivates them, have volunteered to help, right? And at some point, I'm sure you will be in the position to go and call in that favor.
Now, it might be by now that you kind of overwhelmed with all the information that you need to know about other people, about their world, about their currencies, about their motivation, what they do, what they want, what they expect, and this is a lot. But The good news are that knowing the world of other people is what one of the most important concepts of DevOps is. This is called the T-shaped people, and this is about when you have your expertise, and Alex in our example is an ops person, they know ops very well, but they also learn the world of other people, and they know about dev, they know about QA, they know about security and products, etc. Not only it helps them in their work once DevOps is implemented as a mature, because the empowered teams are the teams of T-shaped people, but it also helps them actually influencing for DevOps, because they have to understand everything in order to be influential for DevOps.
So that brings us to the end of the model, and therefore the end of our talk. You now should be equipped with all the theory on DevOps and influencing without authority that you need to go and create a successful transformation, right?
Leonid, come on. It's all nice and fluffy in the books, but we know what will happen.
You're absolutely correct. In the next part of our talk, we wanted to walk you through some of the concrete objection handling and giving you some tools and techniques that you can use to get to yes and getting through no. Some of the barriers that you're going to be facing to influence will come from things that you don't control. There will be external barriers, right? And we'll give you some concrete examples. For example, the very first barrier we've encountered in our talk was Alex, which is the power differential of being very deep in the organizational chart and trying to influence the top authority in the organization directly. The different teams, as we've learned through OKR discovery, may have incompatible goals that may prevent you from being able to partner with them. And it's important to understand that that's a barrier that has to be overcome. Different measures, right? OKRs. Some teams may be motivated on things that will be in contradiction with rolling up modern processes, or they just have so much stuff to do, or the measures are so high, they may simply don't have time to partner up with it. And this has nothing to do with you or your ability to influence. And then, of course, there's the good old inter-team rivalry. Companies like Microsoft are famous or infamous for that. And you'd have to be aware of that organizational dynamic before you attempt to partner with somebody up.
Another type of a lot of barriers is purely internal. It's something in you or the person that you are trying to influence. For example, lack of experience. You heard us about explaining the model. You might read the book about the model. Only practice makes perfect. You have to try it before you know how to operate it well. Blinding attitude. Statements like, I will never be able to convince this person, will prevent you from trying even. Don't do that. Fear of failing. You might say, you know what? I will never succeed to transform my entire organization. I won't even try. Inspiration, like we hope this talk will provide some, is actually how you battle this internal barrier. And I think one of the most dangerous are fear of reaction. You afraid to do something because you know that you have to come to work tomorrow and deal with the consequences. To deal with fear of reaction, I would suggest always having best alternative to negotiated agreement, or BETNA. BETNA is about what happens next after your attempt to influence failed. The worst BETNA is not having one. I didn't think about it, or I will try and pretend that nothing happened. Trying and pretend that nothing happened actually is one of the biggest contributors to the fear of failing, because you cannot go all the way in your persuasion efforts, because you're afraid you cannot undo it. Now, if you realize that you cannot undo it and do it anyway, your next plan may be, well, if this goes wrong, I will have to go and look for another job. Looking for another job is stressful, is hard, so this might prevent you again from going all in. The only way you can negotiate in your full or negotiate and convince in your full power is actually having an actionable best alternative to negotiated agreement, which might be, for example, a job offer from another company. If you have nothing to lose, you will be at your best in negotiation and influencing.
It's also important to remember that sometimes you want to lose the battle while winning the war. So not every attempt you will make at your transformation will be successful, and you're going to have to pick and choose which battles are very important for you to win the overall war and which ones should be lost. And it's very important when it comes to that to remember that you typically have one opportunity at times, at an exceptional case, maybe couple, to take your shot at the transformation or to take a shot at convincing a stakeholder or convincing a team to partner you. So don't waste your so-called silver bullet unless you come prepared and you're ready to go.
And I think the last part of this talk will be practical examples of people's objections.
Let's talk about some of those objections. Yep. Let's use a typical developer, and you may hear an objection that, the sysadmins want DevOps because they want me to be on call 24/7. On call is not my job. I'm here to write code.
For that, we have a great answer, which is incorporated in the entire talk. If you go to the other side here, if you go to the show notes, you will find there a link to another talk, DevOps for developers, or maybe against them, which answers this fear exactly, the fear of developers of DevOps.
So anyhow, let's forget about the developers' objections. What's wrong with what we're doing right now? We're a successful company. We've been established hundreds of years ago. We got this software thing figured out. Why do we need to change?
Well, the world changed. The consequences of not doing DevOps or doing DevOps wrong today are daring. You can remember the example of Equifax and their SEO, who, according to the register, fell on his sword for a security breach that Equifax didn't have the DevOps procedures to patch on time.
Very well. But you know what? Fine. You convinced me. We certainly don't want to end up in the newspapers, but everybody is busy. We're already trying to keep up with everything else going on in the business. We have some competitors nipping at our butts, launching new products. We got to work. We don't have time for this transformation thing.
Everybody are overloaded all the time. And sometimes you have to make time to take your head out of the water and see how you can be more effective. With DevOps, it will help you to do the right thing and be overloaded less. So it's good to spend time in order to gain this time later.
Well, maybe fine. You also keep talking about this T-shaped personality things. Silos are good, right? We have people that specialize in building software, deploying software, securing software. Why this whole idea of learning a bit about everybody's world? Aren't they going to be all mediocre at everything then?
Well, specialization is great, but you need to remember the goal. As another great book by Eliyahu Goldratt, The Goal, teaches us, we need to, not everybody to be perfect, we actually need to optimize at the bottleneck. You might have the best specialist in a place which is not the bottleneck of your pipeline, and this will be completely useless to your productivity. This is why T-shaped people are important. They help you to determine what the bottleneck is and optimizing there.
I also talked to my friend who's running a regulated shop. They have PCI DSS and HIPAA related things. And he tells me that those regulations they don't allow for DevOps. You have to separate concerns and you need to segregate duties. How can we even do that? We also have to be certified pretty soon.
Yeah, this is actually a great question. And the answer to it is stop certifying end product and start certifying pipelines. Once you certify your pipeline, by definition, all the products that come out of this conveyor will be certified. And this is how you overcome the problem of certification.
Very well. I'm also confused. You talked about like good teams releasing faster, but you're also talking about like making sure we're secure, because in this day and age, we have to be secure so we don't end up in the newspapers. Well, how can we release faster if we have to certify every release for security? We have to run a pen test. We have to do some manual testing. Like, we can't release faster.
Yeah, that's another great concern, because in the end of the day, we want to ensure that everything is right. But again, once we teach our machines to check for those details, we don't need to stop the world and check for it ourselves. So once we give up control to the machines that we teach how to do the work for us, we can actually release faster.
Well, with that, let's go back to our mythical hero, Alex. And Alex has mastered the art of influence without authority and has managed to transform Strong Fabric's core, and has been so successful that Alex is now the CIO of that company, and that set his resume up for success. And he got headhunted and joined another company to help them with that similar journey. So hopefully some of the lessons you took from this talk will set you up for your professional success with your own transformation where you are right now, as well as many other transformations to come. And to summarize some of the key items, remember the model from the book, the 6-step model, and you can always go back to the talk for some of the reference ideas on how to apply that model concretely to engineering and software engineering practices. And
also remember that you work with people, and people are predictably irrational. You need to battle their fears. You need to be able to overcome objections, and you need to think of how you're going to approach it before you actually going to this battle. So with that,
would like to thank you for your time.
We'd like to wish you good luck in your DevOps transformation.
I am at, this is Jay Baruch.
This is Leonid Golnik, Eli Golnik on Twitter. This is days_dev. That's the hashtag of DevOps. The handle of DevOpsDays Kyiv. And just to remind you, you know where to look for the slides, the video, all the links, comments, rating, and a very, very lucrative raffle. Thanking you for being here. With that, questions. Thank you very much.
Okay, thanks for the great talk. I enjoyed it. I hope the audience enjoyed it too. So I was right when I introduced you as Don Leonid and Don Baruch, because it was really, it looked like, a DevOps mafia trying to take over the company and then maybe trying to take over the world. So it's exactly about that. Funny enough. So let's move to questions. So the first question is, well, I remember a recent podcast with Sam Boyer and got a question related to that talk. How much time does it take to grow a beard as great as yours? I think that's a question for Mr. Baruch. But
yeah, sure. Great beard, right? They didn't say any beard, they say great beard. So.
Great.
No, I'm just kidding. I think it's different for different people, and for me, it's just the way it is. That's thank you for the fun question, but this beard been with me for I think 2.5 years by now. It's usually much more groomed and trimmed, but today when our barber shops are closed, It is what it is.
I have a quarantine beard, as you can see. So, Leonid, what about you?
Mine is an experiment. Baruch and I actually use the same barber, and unfortunately, he cannot work right now. So I don't think I'm doing him justice experimenting with some new hairstyles. Mine is mostly quarantine beard.
Okay, so the next question it's deep into the philosophy of DevOps and stuff. So we have DevOps engineer in the title today, but as we all know, there are no DevOps engineers, and you cannot hire one because DevOps is a process, not a person. But there is a suggestion. So do you think we should maybe in some point in time just to get along with that, just to buckle up and make things easier for recruiters and project managers and QAs, and so they just know, it's a DevOps guy. So what do you think about that?
Baruch, I know you're
I
passionate
think,
about the topic. Why
yes,
don't you start?
I am. Yeah. Yeah, so I think the term DevOps engineer did us a lot of harm in the last years, because it kind of assumed that DevOps is an engineering discipline instead of focusing on the methodology and the practices around it and the culture around it. But it's also very clear today that when people say DevOps engineer, they mean a set of skills. So although I personally hate the term, and I claim that DevOps engineers do not exist, because DevOps is about collaboration, what collaboration engineer even means, for now it's kind of standard de facto that people refer to both the recruiters and the applicants. So it's kind of I feel that it's a little bit lost battle for me. I still keep fighting it, but I think most of the time when people say DevOps engineers, they mean service reliability engineers, and I would love people to use the correct terminology, but they don't.
Yeah, that's actually interesting. So you started the presentation. You guys started the presentation with a slide of what company can do to get things better, and you forgot to mention very important thing that many people are doing. You forgot to mention hire a consultant firm that is going to join and fix all problems. Obviously not, but that's just one of
this meme has only 2 slots for wrong opinions, so I had to pick my battles.
You can change it for the next presentation to make a difference.
Yeah, we can interchange. Yeah, we can use different wrong approaches to DevOps. There are a lot of them. Leonid, go ahead.
No, I'm a consultant right now, so I have nothing else to add.
Oh, exactly. Try to look beautiful and say that consultants work.
Yes.
Well, I think consultants have a place in an environment where, instead of reading the book, you need somebody who has experience from the trenches to unlock the transformations. Because sometimes to get that activation energy that we talked about in the talk into the conversation or into the company, you need some very concrete examples, and you typically create those concrete examples through observations of what's happening at the company and pattern matching those observations to your previous experiences. And I think having somebody come in from outside of the organization on a more serious note does have a benefit of helping people understand some of those negative patterns and how to tackle them to get the transformation going. But solely relying on a consultant to do a DevOps transformation is a heresy.
Right. So the final question, can you agree or disagree with the next phrase? Engineers of DevOps are chopping branch on which they are sitting statement. What happens when everything would be DevOps?
This is a great question.
Yeah, I think there was a great talk targeted. Yeah, I was about to mention it. There was a great talk done at the test conference, and the title of the talk was "We do DevOps now. Let's fire all the testers." Because of course, right, you're going to automate everything, and who needs exploratory testing? I think it's not about automating yourself out of the job. It's about changing the nature of the job and changing what you're burning your calories on. And I think we as civilization could say we've been automating ourselves out of jobs for years, right? None of us most of us at least, don't grow our own chickens or make our own cheese and milk. We outsource of those things so we can focus our energy on something else that may matter more to us. And I think it's a similar experience here. The mundane, repeatable stuff that will be done by computers should be automated, because if you're not going to do it yourself, somebody else will. But you should be thinking about how do you evolve yourself in your own vertical, in your own discipline, whether it's development, engineering, security, to focus on much more impactful things that computers are not good at.
Right. And on that note, we need to go on a break, and we will be back in around 8 minutes at 8 and 10 minutes. So please just wait for a while, and please go join our video chat rooms. We have some changes, so please see new descriptions and go to the Zoom links. And the next presenter will be Kris Nóva. See you in 8 minutes. See you.
I have one disclaimer. Unfortunately, the show notes platform that I sent you to, that we numerous times sent you to, the jeffrog.com/show notes, has a little bit of technical problems, as the theme of the day is technical problems. We are fixing it right now. It will be probably up and running in 10 minutes. So don't forget to cycle back. Stanislav, I would appreciate if you mention it once again after it's up and running, when you maybe after Kris talk, so people can know to go there when all the resources are there. So thank you very much.
And
it was a pleasure.
Baruch and I will be hanging out in the chill out rooms for a bit. And if you have any other questions that you cannot get answered either there or in the YouTube chat, just ping us on Twitter at Ali Golding and at Jay Baruch.
See you all in 7 minutes.
Thank you.
Oh shit! As always, I forgot to unmute myself. But hey, that's a day. That's a day. So please connect. Please have a seat. Let's continue. Let's continue. So before we move on, let me introduce our sponsor today. Our sponsor. Okay, just a second. We don't have. That's because I have a Zoom running. Just a second. Is that better? Can anyone hear me? Hey guys, do you hear me well? Oh, okay. So that's because I had a Zoom running on the background to keep the spare Zoom room. And well, that's why it took the microphone all over. What a day. Anyway, so let's continue. So before we move on, let me introduce our sponsor today. Our sponsor is Wix, and Wix is a leading cloud-based web development platform with more than 150 million users worldwide. And Wix was founded on the belief that the internet should be accessible to everyone to develop, create, and contribute. Our software engineering culture is based on developers who love their work, are passionate about technology, and believe that nothing is impossible. So let's see our guest from Wix today, Maxim Shkolny, with a very short 5-minute speech, div2 for TF file. So Maxim is a Linux enthusiast who have been in industry for 7 years as a system administrator, as a DevOps engineer, and as a Java programmer. Currently working as engineer in Wix systems. So Maxim, please go ahead.
Hi guys. Okay, let's go on and present something. So, as you know, my name is Maxim Shkolny. I am a systems engineer at Wix company, and today I'm going to present you a small handy tool for computing difference in Terraform files. But first of all, let's describe in which context do we use this tool and why do we need it. Wix is a big company. We have a huge infrastructure, and that is why we would like to keep our Terraform state smaller, and we divide it. But how? We have a concept of environment and layers. And as you can see on this grid, on the intersection of environment and layer, we store our Terraform states. That's how we split it. Our Terraform files are generated, which means that we have infrastructure definition in some format. Current format is YAML files, for example, and we generate Terraform files. And after this, after applying Terraform, we have Terraform state. Users commit to the infrastructure definition, not to the Terraform files directly. Why? Because our Terraform states are pretty big for human. Usually generated file, TF file, can contain many thousand lines of code. And if you are not a robot, it is pretty hard to maintain it. But okay, if our Terraform files are generated, are they applied? They can make mistakes. Somebody can underestimate the effect of his commit to the infrastructure definition, or just simply forget to apply something, to forget to specify some target. And what we will have in this case, we will have Terraform state drift. It means that after a commit and apply of your changes, your infrastructure definition will be not equal to your Terraform state. You can ask why people do not just apply a whole Terraform state. It is simply we have still huge Terraform states, and it is time consuming. We have a bunch of users who use Terraform, so we do not want to create some obstacles. Okay, so what is the solution? It is pretty simple, just to help people to pick the right targets. And let's make a short demo. First of all, we have to clone our repository. Then build a tool. I'm showing you like to do this from scratch. It's pretty easy. Let's specify the output. So I pre-generated Terraform file. Let's show you what is inside. 3 resources, one AWS instance, and we also have Route 53 record and AWS CloudWatch alarm. Let's make some changes to compute difference. For example, let's split these files. Make some changes in some fields. For example, let's put here some smile and change the TTL. And let's go to the next. A separate file, remove commit, and maybe modify some another field. Let it be. So now we have modified files. Let's put it to a separate directory. And let me show what will be if you compute difference with simple Linux utility. It is not pretty useful. You can see that files were changed. But if you want to compare some file, you will see a lot of output, and it is not pretty readable for a human. And consider that this is a small file. Okay, let's use our tool. Let's just put two directories, and in comparison, we can see that this tool combined two files. We can see which Terraform resource was changed, which attribute was changed, and the exact line that was changed. In the blue color, you can see the link to the file and the position of the changed line. Also, we can produce just a list of changed resources. It can be used in our Terraform, for example. Let's continue I would like to tell you what is under the hood. Basically, we use Mayer's diff algorithm. It is the same algorithm that is used in the Linux diff utility. It is a greedy algorithm, means that it makes conclusions each step while going through the program, and complexity is O and D. It means that it is n proportional to the number of differences that you have. Let me quickly describe how it works on strings. For example, we would like to compute difference on these two strings. First of all, we have to find the longest common subsequence. It is a pretty well-known computer science problem. In our case, subsequence is A, K, and S. It is common letters in these two strings, and the size is 3. Sorry. To compute it, we need to create two-dimensional array, put an extra row and column with zeros, and start iterating over it. First step is to compare upper and left cell and pick the biggest values. In this case, 0, 0, we pick 0. Continue until we have a match of letters, A and A. In this case, we make a diagonal move to the upper left cell and increment its value by 1. We have now 1. Let's go on to the next submatch. And next, now we finish. We have number 3, it means that the length of the common subsequence is 3. And how can we compute the exact letters? Pretty simple. We go backwards, and each time when we make a diagonal move, we pick the letter. So in this case, 3 to 2, it is letter S, we pick it. 2 to 1, it is letter K. And now we do not have a diagonal move. We go up to the biggest value from left and up. And now we have a diagonal move. So we pick letter A. Basically, that's it. Thank you for your attention. And now it is time for question and prizes. The first 3 persons who answer correctly a question will get some prizes from Wix. So the question is, what is the name of markup language used by Terraform? Please feel free to answer it. Thank you very much for your attention.
Please leave your answers in the comments, and we will contact the first 3 people and provide contacts of Wix to get the prize. By the way, Maxim, what the price is?
Actually, I am not aware. It is a
okay. But that's something valuable. Not as valuable as an iPhone, but maybe something substantial. Okay. Let's continue. So,
okay.
Bye, Maxim.
Bye.
So let's move along and let's continue. I'm proud to introduce our next speaker, Kris Nóva. I'm proud to introduce our next speaker, Kris Nóva.
Hello, and this is a check. Can everyone hear me okay? Check 1, 2. Hey, okay, yeah. I think it's working. I'm not anticipating hearing anything back at this point. So I think we're ready to go. Oh, the joys of doing remote presentations. I'm very excited as I've been watching more of these live streams about what potentially could happen in the technical industry as we depend more and more on doing these things remote. The technology that is about to arise, I have a feeling, is going to be pretty exciting. So anyway, let's get started. I think I have about 45 minutes here to share with folks. Today we're going to be talking about ptrace with a runtime security tool called Falco, and we're going to be running that in AWS, and we're going to go on a bit of a technical journey, an evolution, if you will, of how we got here today in the wonderful world of DevOps and containers and Kubernetes and runtime security. So to get started, what we're looking at now is I'm going to do a quick screen share from my terminal. And what we're looking at, I have a public GitHub repository, and I try to do my demonstrations from the command line to capture the world that I pretty much live in my day-to-day life as I'm working on these low-level constructs and these lower-level primitives that we use in runtime security. So what we're going to do is we're going to run a command line tool that I wrote called ZOMG, and we're in a directory called Keynote. And my slides for today. So to start off, the name of the presentation, I'm calling this Serverless Runtime Security with Falco and Fargate. And the serverless component is going to be very important here because that's going to describe the constraints for the problem that we had to solve. And by solving the problem for the serverless constraint, what we discovered is we actually enabled other solutions to be created with the technology that was created for the problem for a different use case. So I find what happened here with Falco and with the company I work for, Sysdig, to be a very exciting technical journey. And this is a great example of brilliant engineers coming together, solving a problem, given a very challenging constraint, working with cloud providers in the public, working with the open source communities, and coming up with a really elegant and really powerful solution that literally overnight has already created other technology. And I will talk more about this new technology that was created last night here in a little bit. So for those of you who don't know me, I would like to just start off and say hello. My name is Kris Nóva. If you're watching this live, if you're on the Twitch stream, I have it pulled up right here on my iPad, and it helps me if you could just say hi and let me know that you're here. And if you have any questions or something seems confusing, I very much want to capture this as a live event. I'm literally standing in my living room talking to a camera and my lovely audience here in front of me. So capturing the energy of doing this live it's what's very important to me. So I'm an author. I co-wrote a book called Cloud Native Infrastructure. I've worked at Microsoft, at VMware. I was part of the Heptio team. I now work at Sysdig Incorporated. We're a security company. We're based here in San Francisco. I'm our chief OSS advocate. I work on an open source tool called Falco, and my company does enterprise solutions around the open source software that I am in charge of running and maintaining. And it's a wonderful place to be. I'm very happy to be here in California. And I'm really stoked to be working on the CNCF-sponsored Falco project and being able to do all of this in open source so that I can share it and we can share it with the open source communities as we develop these technologies. So anyway, oh, hi folks. Hi, sound is great. Good to see you again from Finland, and hello from Dublin. Cheers, hello, welcome. So anyway, I fancy myself a hacker. That is, I like to find problems that have not been connected or glued or represented in a use case and build that. And today we're going to be looking at not a solution, but a proof of concept that I was able to build and hand over to the world and empower other folks to start building more powerful technology. And it's been very exciting to be a part of this whole process. So to start the conversation off, any good technical conversation should have a well-defined set of keywords that you're using. If you've ever looked at developing your own programming language in the past, having the keywords set aside and well understood beforehand is important. So to simplify things, we're going to start with 3 keywords that I will be repeating throughout the length of this presentation. Hi from Brazil. Hello, good to see you. The 3 keywords are prevention, detection, and kernel probing, event tracing, kernel instrumentation, kernel observability. I use the word probing because BPF typically refers to the implementation as a kernel probe. But regardless, this is the act of observing something in the kernel. How do we understand what the kernel is doing at runtime? And you see like implementations of this solved in different ways throughout the ecosystem. And we're going to be exploring some of these and how they relate to Kubernetes, containers, and serverless moving forward. Okay, so for folks at home, if you want to go ahead and do like a print screen on your computer, grab a copy of this. These are going to be the links that I will be referencing and the place you can record if you want to come back and find out more information about any of this later on. So if you want to grab this now, save it, and as we're going through the presentation, you can reference these. Feel free to go for it. I'll run through them just really quick. The first one is the Twitch stream, SetNS, brought to you by Sysdig, that we are currently running on. This is where I'm engaging with folks in the chat. If you want to come and ask questions, there is the DevOpsDays Kyiv chat, and unbelievable shout out to the lovely conference organizers for bringing this together. It took us almost all week long of trying to schedule across time zones, figuring out Zooms where I'm on one Zoom here and I have another computer with a Zoom here. And these folks have been amazing community and have really enabled myself and the other presenters here to come and bring this to you today. So huge shout out to them as well. And they were kind enough to stream the entire event to the SetNS Sysdig Twitch channel. So if you just wanted a quick and easy way to come in and engage throughout the course of the conference, feel free to come here and remember to thank the conference organizers. These folks have gone above and beyond. The next one is my public speaking repo. This is just where I write all the slides that you see here, and I check them into source so I can work on them across various computers. If you see anything here that you like, or if I made a typo and you want to open up a PR, please do so. The slides are intentionally small. It's just raw text, and there's a small interpreter that displays them on my screen here so you can see them. If you can't tell, I'm a fan of simplicity. So anyway, there's a couple of repos. There's Falco Trace, which is a toolbox that I built as a proof of concept that demonstrates a lot of what we're going to be talking about today. And the exciting evolution of that is the Falco Inject project that is written in Go by the author of BPF for Linux Observability, Lorenzo Fontana, who has come up with a way to use the ptrace and the paradigms that we're going to be talking about today in Kubernetes, and actually attach Falco to a running Kubernetes instance, a running Kubernetes pod. So if you're interested in seeing the development there, Lore has put that together for us, and a big thank you to him for his hard work. And again, this is exciting to see how this is evolving day after day as we go forward. Last but not least, you can see the announcement. It's on our sysdig blog, sysdig.com/blog/Falco support on AWS Fargate. And this talks about how sysdig has written these open source libraries, these open source tools, came to the Falco community, proposed for these tools to be adopted. The Falco community went through our process and adopted these tools, and now all of this is happening in upstream. So if you want to understand more about the technology or how this relates to AWS and AWS Fargate, you can go find out more on that blog there. Okay, let's get into the nitty-gritty details here. So the first word we're going to talk about, I love this slide because this is probably 1/4 of a kilobyte of text, and it's taking up my full screen right now. The first word here is prevention. And we're going to explore not only what this means from a security perspective, but we're going to explore implementations of prevention tooling as they exist today and as they have existed over the past several decades in both Linux and Kubernetes. It's cool because I can see myself on my iPad about 30 seconds behind here, and I just saw myself do this, and so it was kind of exciting. So with prevention, what we have here is I've taken a stab at defining it, which is the exercise of preventing unwanted action, locking your door, telling someone to go away. This is a fundamental concept in humanity that is, I would like to prevent something from happening. So the interesting thing about this is prevention requires you to be aware of something that could potentially happen in the future. If nobody had ever broken into somebody's house before, would there be locks on the door? And so the idea here is that in order for you to prevent something, you have to first be aware of it. As we have seen over the past few months, there are things that can happen in this world that the world simply isn't prepared for. And this happens in software quite often. We're all familiar with 0 days, with CVEs, bugs in our code, bugs in others' codes, bugs in the libraries that we depend on. And a large portion of software engineering is triaging these and fixing and patching these so that they don't happen again. But if you look at the philosophy behind this, what actually happens is somebody learns about a potentially unwanted behavior, and then we take actions to prevent that. This fundamentally is the entire concept of regression testing. This is why engineers write regressions, so that we can prevent against unwanted things happening in the future. But in order for us to do that, we first had to be aware of these unwanted things in the first place. So let's look at some very successful prevention tooling as it exists in both Linux and both Kubernetes and containers today. The first one is SE Linux, which anyone who has ever taken a long, hard look at securing an enterprise Linux system has more than likely come across the SE Linux man page. And without going into a detailed analysis of what SE Linux can and cannot do, I think it's important here to bring up that it is fundamentally a preventative tool that gives the user, the administrator, the control to prevent what people in user space can and cannot do. Somebody in the Slack just said set enforce 0. If you're an SE Linux user, of course, that's the 777 of SE Linux. You can just set everything wide open. And so anyway, it's basically a configuration language that allows you to take control against how the user space can interface with the kernel. And there's other tools that do this as well. setconf and setconf BPF are very popular implementations. In fact, as we get into ptrace and the internals of the ptrace library, setconf BPF is going to be a fundamental part of this. Setconf BPF allows you to define what a process can and cannot do at the syscall level. You can take one of the many hundred Linux syscalls that are in existence today, and you can simply say whether or not a program in user space can or can't use those syscalls. And if it violates that, you effectively can kill the process. And so that gives us this preventative control over what folks can and can't do in user space. Now, again, we first have to be aware of something malicious, which means you need to go take a long, hard look at the Linux man pages and read about all the various system calls and understand the security implications with those. And that's a lifetime of work. I have met folks in my life who've been using Linux for their entire career, and still, myself included, and other folks I would consider a Linux 10, still need to go and research the documentation on some of these man pages and some of these syscalls just to understand the implications of using them. And so we see this in the kernel, that you can go through and you can control what these processes can and can't do. Now, interestingly enough, I'm sure we've all heard Kubernetes being compared to the Linux kernel. We also see these paradigms in Kubernetes and in the container world as well. A very good example here is the Kubernetes admissions controller. And I put together a very, very high definition diagram of the Kubernetes admission controller we're going to look at in a moment. But effectively, this allows you to govern, given an arbitrary set of logic, what can and cannot be saved in the Kubernetes database. If you look at how Kubernetes works, the API server is the gateway of control. The API server's responsibility is to save accurate information into a database. And there's other components of Kubernetes that read that data and then go and reconcile the state of the world accordingly. And so there's this trade-off where the database is the source of truth. And that's kind of the principle, the underlying principle behind Kubernetes and how it works. And an admissions controller is effectively a gate that controls what can and cannot be saved. So we see implementations of this. There is a very successful cloud CNCF project, just like Falco, that we're going to be looking at in a moment, called the Open Policy Agent, or OPA or OPA. And this has many use cases, but it's effectively a framework that defines how users can describe policy. But as we see with SE Linux, with setconf, and with admissions controllers, the policy is where the value is. A firewall is only as good as the rules that somebody creates for it. And so what OPA does is effectively gives people a framework for standardizing how we would express this policy moving forward. And we see a concrete implementation of that in a tool called Gateway, which I first learned about when I was connecting with my colleagues over at Microsoft. And Gatekeeper basically recreates pod security policies using this OPA expression language called Rego that can then go and prevent unwanted behavior using a Kubernetes admissions controller. So we're seeing these paradigms and these principles being created to prevent things from happening in Linux and in containers from a security perspective. And that's a powerful, powerful way of approaching security. So here we have a diagram of setconf in mode strict. This is the strictest mode you could potentially run setconf in. And this is a very simple diagram that explains exactly what you can and can't do. On the left side, we have user space, and on the right side, we have the kernel. And here we have 4 avenues in which we can communicate with the kernel. Exit, read, write, and sig return. Everything else is effectively blocked. If you tried to call open while you were running a process with setconf mode strict, that process would be killed because setconf is effectively blocking these system calls from being executed. So you can see here that the gateway is effectively working like a firewall between the application and the kernel. And that's this preventative action that we're talking about that we see represented in higher level tools like Gatekeeper and higher level tools like OPA. So here's the Kubernetes admissions controller. Here we have a manifest.yaml, which is, I'm sure we've all looked at some sort of YAML before in the past. And then we send that over TLS encrypted HTTPS up to the Kubernetes API server. And in the first few versions of Kubernetes, we would just blindly save that to, well, not blindly, but there would be very little validation into this, this YAML other than does it actually fit into the shape that we describe and that we call the Kubernetes API. In later versions of Kubernetes, we see that we now have this concept of an admissions controller. And this admissions controller allows us to write logic that says whether or not we should allow any of this to happen. Again, it's the firewall for Kubernetes. The logic could be something as simple as, does it contain a given string? Does it not contain a given string? Does it contain some key or some label that matches some arbitrary value or some small condition or some small set of logic or a small system? And OPA allows you, or OPA, Open Policy Agent, allows you to express this. And then if everything works great, it's saved into etcd and the rest of Kubernetes takes it from there. And if not, then it returns with an error to the user and says, I'm sorry, your YAML is invalid. Okay. So let's talk detection. Now, this is the bread and butter of my company and what I do for a living and what Falco does, is we have created software that allows us to observe the kernel at runtime from user space and detect when things happen that we were not expecting. And this idea is fairly common in the ecosystem. You'll see other tools that can be used to do this. And if you look at the history of our founder and CTO, Loris Stagioni, he was one of the original creators and engineers behind Wireshark and started one of the first companies around it. And his philosophy behind a lot of this is that the network used to be the source of truth, and now we're looking at Linux system calls as the source of truth. But regardless, we need a way to observe this. We need a way to see it. And once we begin seeing it, we can then begin to assert if things are happening inside of it. So this is why we're all here today to talk about ptrace. So I'm going to read the first few sentences from the ptrace man page during my DevOps Days keynote here. Omeg says, yay. The ptrace system call provides a means by which one process, the tracer, may observe and can control the execution of another process, the tracee, and examine and change the tracee's memory and registers. It's primarily used to implement breakpoint debugging and system call tracing. Now, ptrace is a system call, and this is how you would engage with the kernel. So let's look at a diagram of how ptrace would work. We're existing in user space in an application. And let's say we're writing a C or a C++ application. We could then use a library like glibc to execute a command against the ptrace underlying syscall, and that would go and it would take action in the kernel. And this gives us a common avenue where we can communicate and potentially control, if we go back, examine and change the tracee's memory. We can observe and control the execution of another process. This gives us that avenue from user space to take action and control in the kernel. So let's look at a runtime security tool called Falco, the tool I work on every day. It's a CNCF incubated tool. And this is traditionally how Falco has worked and what Falco does if you go and you run it today in Kubernetes. So there's a user space component that we call the Falco user space component. It usually runs either as a daemon, you could run it in a container, but it is the part of the system that you would look and see from the command line. Are you seeing now why I do everything from the command line? Because the highest part of the work that I work on exists here. And so underneath that, we have two libraries, libscap and libsense. It's a capture and an inspection library. And those standardize how we engage with events from the kernel and basically recreates the state of the system at runtime so that we can then assert that against a set of rules. And we call that engine Falco. Now, the way that it worked originally was it used a kernel module that executed against a ring buffer. And so we were able to take events out of memory from the kernel and I use the term bubble those up to user space, where we can then go and take action against them and assert rules against them. And that gave us our first avenue into the kernel using a kernel module. Now there's trade-offs with using a kernel module. One of them is you're basically injecting logic into the kernel, and that's a concern for folks, as it should be. Any kernel should be a concern for some folks. In any arbitrary logic interfacing with it, I would like to know what's going on there. And that led us to our next evolution of this, using a tool called, or I guess I should say a feature called BPF, Berkeley Packet Filters. And if you look on the right side of the diagram, you can see how that kind of exists above the kernel. And that gave us read-only access to a virtual machine running in the kernel, where we could then perform the same tasks. Now, we engineered this in such a way that those tasks would always be translated back to the internal form that those two libraries, SCAP and Sense, were expecting, so that you could seamlessly flip out the kernel module with a BPF probe given your use case and your constraints. BPF is technically considered safer, as it claims that it cannot break or cause a system crash at runtime, whereas kernel modules, if there's some anomaly or some known bug in the kernel or your code or something changes, could potentially deadlock a system. So BPF was a much more resilient solution to solving these kernel problems. So this week, we were able to connect the work of a few folks in the Falco community, Loris, a guy who works for us named Greg, and they've been doing a lot of work with ptrace and taking ptrace and basically re-implementing strace, and then taking that and giving that to those higher level libraries, SCAP and Sense, in the same way that the BPF probe or that the kernel module would do moving forward. And then Falco almost seamlessly can just run and observe these libraries and these underlying events using ptrace as one of our 3 options for consuming information from the kernel. Now, what's interesting about ptrace versus the other 2 approaches is ptrace is it's concretely married to a process. So granted, you could run it on PID 1, or you could run it across any PID in your system. You would then begin to observe and potentially control the underlying kernel implementation for that specific process. If you look at the kernel module or the BPF probe, system-wide, you get it installed on your system, and we have the keys to the kingdom. We can see everything. And that's where one of our company mottos, we go deeper, we dig deeper, comes from. So let's kind of recap what we just talked about here. Detection. It's recognizing when something unusual happens, something unexpected happens, something you weren't anticipating. And another way of phrasing that is anomaly detection. And we do that by observing the fundamental elements of our system. Linux system calls. Some concrete examples of detection tooling. Wireshark. It observes the network. If you're trying to debug a network problem and you want to see what's going on your network and understand it, if you want to validate that the source part of the datagram actually is what you're expecting, you use a tool called Wireshark. And that gives you visibility into those lower level primitives. We recreated that with system calls with a tool called Falco and a tool called Sysdig. And you can run that. They're free and readily available in open source today. And we have been able to take that and apply that to Kubernetes. There has been some drawbacks with how we install this, because fundamentally we need to get involved with the kernel, which is why the ptrace discussion is so exciting as we get more into understanding what ptrace is able to do for us in the world of serverless. So what Falco does is it takes these system call events, either from ptrace, either from a kernel module, from the BPF probe, and it ingests them at runtime. We also can consume container context and Kubernetes meta information and other arbitrary information from various APIs as well. We amalgamate that together, and then we assert that against a set of rules, and then you can configure an output. You can take action. Do you want to write to a log file? Do you want to call a webhook? Do you want to have some gRPC client written in a different programming language consume one of these events? You can. And that is the principle behind Falco, the Falco project, and how we're able to build runtime security detection tools against what's happening in your kernel at runtime. And here in a moment, we're going to hack into a container running in Fargate, and we're going to actually do something malicious, and we're going to see Falco alert about it. Okay, So in summary, security via detection. Something unexpected happens. Sometimes these things just happen. It's part of software engineering. It's part of being a human. We grow, we change, we evolve, we learn, we get better. It's magnificent. Like I said at the beginning of my keynote, I'm excited to see how technology and conferences are going to evolve. This is what we do. With that evolution comes change, and with that change comes unexpected behavior. It's just a part of life. Being able to detect this becomes a top priority. We would like to know when something changes. And so that's why we have principles like intrusion detection, alarms, alerting. Every person watching this who is a DevOps, I know in the previous talk we talked about not using the term DevOps engineer, but every person here who has been mislabeled as a DevOps engineer is probably familiar with getting some sort of a notification when something goes wrong or something unexpected happens. When I spent time working as an SRE, mislabeled as a DevOps engineer, I cannot tell you how many camping trips I had to postpone because while I'm on my way to the mountains, my phone went off and I got an alert from Nagios, or we later switched over to PagerDuty. So this idea of detecting when things happen is a fundamental part of what we as runtime engineers and as site reliability engineers or infrastructure engineers have to do. And if you look at how you do that from a security perspective, there's a couple of universal truths here. Detecting requires privileges, period. If you want to see what's going on in the kernel, we have well thought out, well engineered, and very strict rules and software that enforces these rules about how you can do that. And tools like Kubernetes, tools like serverless are designed in such a way that they isolate you away from these principles and these paradigms so that you can't go in and do something malicious or something scary or potentially crash your system. Now, the problem with this, though, is the user space component of your application should be isolated. It should be. That was by design. But securing that, however, does require privileges. Now, the interesting problem that I had to learn the hard way is that folks who want to secure their systems expect to be able to install their security tools in the same way that they run their systems in an isolated environment. So there's our constraint. There's our problem. How do we install a security runtime tool that needs privileges so that we can read something from the kernel in an environment that is intentionally isolated to keep you from doing that? So let's move forward. And here it is written out in plain English. Serverless isolates. In AWS Fargate, you do not have access to running a kernel module. You do not have access to running a BPF application. Until recently, you didn't have access to ptrace, but over the past few weeks, AWS announced they are supporting the Linux capability ptrace. And that's where our software came from. And that is what I'm here to show you today, is this new capability recently released in Fargate serverless that we can actually take and run Falco against at runtime to secure one of these workloads running in Fargate. So let's look at the Falco installation story as an example of the type of problems that we've had to solve in the Falco ecosystem. So if you look at how Falco runs today, it effectively requires privilege escalation. If you choose to run it using the Kubernetes API, for instance, if you are constrained to only using the Kubernetes API and you want to run Falco, Falco runs a kernel module, we're going to need to be privileged to get that installed on your cluster. In fact, there's a lot of tools that have that same problem as well. If you look at most CNI implications, they run a daemon set that actually goes onto your host and takes action against your host. In fact, if you do a kubeadmin reset on your Kubernetes host, the underlying host, you can actually go see the artifacts of the CNI left on the host long after Kubernetes has stopped running. The kubelet daemon has not only stopped, but it's been uninstalled, and those CNI artifacts are still there. kubeproxy does this too. There's parts of Kubernetes that fundamentally need access to the host in order to work. And so managing this becomes an interesting problem, and being aware of it is something that I would like to advocate for folks in the first place, is just being aware that this is a problem that needs to be solved, and people are taking different approaches to solving it. So users want security. In a world of isolation, this is hard. This is hard to solve for. So how we've solved this in Falco is if you are constrained to an API and you do want to run Falco and install Falco using a container only, we looked at running init privileged containers and having a container that starts, requires privileged access and goes and takes action and then exits. And then we can run the rest of Falco long after the kernel module or BPF probe have been installed. And we can then just consume those events from the underlying host. We looked at using systemd as a set of checks and balances so that in case something does happen to your Kubernetes cluster, you would potentially be able to still continue to monitor, secure, and detect what happened long after Kubernetes has been compromised. And we looked at using Unix sockets. There's an open source tool called Celium that uses Unix sockets to handle the communication between the containerized workload and the underlying host as well. If you look at the kubelet, it uses the network, which requires some sort of routing policy to go from the kubelet up to, or from the kubelet to the containerized workload. And that fundamentally is challenging to set up and is subject to change dynamically depending on your environment. And if you haven't seen my FOSDEM keynote, I encourage you to go watch it. I effectively use a tool called NSEdger to demonstrate the power of privilege escalation in Kubernetes and show how Falco and OPA and Gatekeeper could be used to detect and prevent that moving forward. So here we were, the constraint. How do we install Falco to secure a workload running in a serverless environment that is intentionally isolating us away from the kernel when we depend on the kernel itself to run the security tooling against? So we knew a kernel module was out of the equation. AWS was not going to support that. It didn't seem like anytime soon. The same goes for BPF, the BPF probe. And if you look at LD preload, and more on this in a moment, there was some concerns around how we were able to only secure a portion of users' applications. For instance, LD preload effectively tricks the linker into running arbitrary code before it calls, but in order to do that, you have to use glibc in the first place. And as we all know, Golang doesn't even use glibc. So if we tried to go the LD preload route, then we were throwing Go out of the equation, and that obviously wasn't going to work for us either. And then ptrace was opened up in Fargate. So let's look at LD preload. Like I said, it effectively tricks the dynamic loader, and you can't even statically link with LD preload anyway because of the way that it is used when you compile your code. It requires glibc, there's no Golang, and effectively it's a hack in user space. You're tricking the loader into doing something that the user potentially wouldn't want it to do. So let's talk ptrace. It is the foundation for strace. If you've ever run strace against a PID, if you've attached strace or strace against a PID, running in your system to debug something, number one, I'm so sorry. I apologize. It's not fun to do, especially when something's wrong. And number two, if you actually go and look at the source code for strace, there's ptrace written all over it, process trace, and it's a part of Linux. You can go read the man pages. Something to point out is it could potentially be attached to PID1, and if you're familiar with PID namespaces in Linux, everything underneath the original true PID1, not an isolated new PID1, could be potentially shared. So if you can get to PID1, you, again, have the keys to the kingdom. And Fargate now supports ptrace, and we're going to look more at that in a moment. And we're going to do a quick demo. And I'm going to show you the code, the libraries, the container, and our AWS dashboard where we're able to make all of this happen. Now, if I could, before I get started on my demo, there's a few things here. Number one, if folks have any questions so far, please feel free to ask in the Twitch channel here. I'm reading it on my iPad. Number two, if anyone here from the DevOpsDays Kyiv team could go to either message me on WhatsApp or go into the Twitch chat where I'm looking at, or I can even look at my Twitter on my phone here, and just let me know how we're doing with time. I know we got started a few minutes late. I just want to know how much time I can have to demo this while keeping the rest of the conference on track. And with that being said, I'm happy to go as long and as deep into ptrace running in Fargate as we want. I have everything set up and ready to go, but I do want to be respectful of time. So I'm going to do a quick check and see if I have any messages here. And it looks like people from Twitter, but nobody from the event. So I will be watching my Twitter, and if there's any updates, feel free to reach out to me. I've got everything here, but I only want to show a few things on the screen share that I'm sharing here with everyone. So Omeg says, I would love to hear about ptrace get syscall info. Okay, so I guess we can do that first. So if you pull up the man ptrace and you look for syscall info, here it is, ptrace get syscall info. It's Linux 5.3. So this is a newer Linux feature. In fact, I'm pretty sure that and I'll have to check on my laptop here, I'm running 5.4 on my server rack in the other room that we can SSH into if we want to actually play with this. But it looks as if this is not available until recent versions of the kernel. Most LTSs that are a little bit older, like you're going to see something probably around the 4.19 range. And that's a few versions after the eBPF features were introduced to the kernel in the first place. But it can retrieve information about the system call that caused the stop. So again, this goes back to, if you remember earlier in my presentation when we talked about how ptrace could potentially control a process. So if you look at how a process is executed in Linux, ptrace allows you to do a stop and stop the process iterator from moving forward. If you've ever looked at a debugger, I know a lot of Java engineers are probably familiar with a Java debugger, or PHP engineers. I've seen some good debuggers there as well. I believe there's one for Golang as well. And what a debugger would do is effectively would stop the process and would give you some control over when to move that process forward or backwards, or not, I'm sorry, forward or to stay where it is currently. And a concrete example here would be, imagine if we were looping over a linked list, and we had our debuggers set up such that for every iteration of the linked list, as we were digging through it, I could hit the space bar and it would go to the next link in the list and maybe echo out a string or some other piece of memory attached to that as well. So what ptrace get syscall info does is it allows you to pull meta information out of the kernel about whatever is stopping your instance or stopping your iterator from moving forward. So again, this goes back to observability, getting information out of the kernel and using that to our advantage. So if something is stopping your process from executing, you could potentially use ptrace to find out what that something is. In fact, just here live, thank you for asking this, Omeg, I'm already starting to get ideas for how we could implement this with Falco so that we could even write a Falco rule that would alert with meta information about something that's potentially stopping the process at runtime. So thanks for bringing this up. This is the first time learning about it. This was really, really good to find out about. And that is ptrace get syscall info for folks who are watching. Okay, cool. So with that being said, I'm going to show a few repositories in GitHub just to set the tone here. Okay, so I got messages from DevOpsDays. It says do demo, 10 more minutes, 10 minutes left, and that was about 10 seconds ago. So we got 10 minutes. And then I'm assuming DevOpsDays, who I'm communicating now with through the live stream and then Twitter, I'm assuming there'll be time at the end for questions on your end, because I believe there's folks watching on your end that I can answer as well. I would love to answer those questions in addition to the ones I have here. So let's look at these open source repositories and talk about what they do. So the first one I want to show you is github.com/falcosecurity/pdig. So in the same way that Strace is an example of using ptrace for observability, pdig uses ptrace and provides information to the rest of the Falco stack for these kernel runtime metrics. Now you can see this looks like the original commit was 8 days ago. So this is very recent. AWS just announced the support in Fargate, and we were so excited about it. We just couldn't wait to share it with folks here. And we have a really exciting demo to look at moving forward. But if you want to see the code, if you want to see how we're implementing ptrace here, you can come through and you can see that we have the C code written. We use setcomp BPF, we provide some filters, and we're actually able to consume ptrace from this code and send it up to the rest of the Falco stack at runtime. So this is ptrace, which this component is fundamental to how we're able to attach to an existing process using Falco. So Loris, our founder, and the other creator of this project, Greg, you can follow them on GitHub here if you're interested. They have done the majority of the work in getting the lower level C libraries working, and a big shout out to them for getting this done so quickly for us so we could do our demo today. So there's this tool, and we donated this to the Falco Security org as a contrib project or as a sub project of Falco Security. If you're interested in getting involved, github.com/Falco Security. You can come to our community here, and you can get involved. You can see the Falco project, and you can see all of our integrations and other sub projects that we have working here. And if you have questions, feel free to come to this community repo, and you can see we have community calls. You could run your own call. We have a Slack channel and a mailing list. We would love for you to get involved if you're interested in how you can use Falco in Kubernetes, with Fargate, with other serverless implementations. If you're interested in ptrace, all of us hang out there. We're nice folks and we're very welcoming. So please come join the party. We would absolutely love to see you. So that's the community and pdig repo. So after pdig came, we thought, how do we actually get this running in Fargate? So the next step that we took was we wrote some documentation in a handful of bash scripts that would build containers. And these containers would be using Falco and pdig at runtime to observe a given process. And we baked all of this into a single container image. So if you come here, probably the easiest application to understand is this one called SSH, which I will be using to demo here in a moment. And if we look at the init script and the Docker file, we can see how this is actually implemented. In the Docker file here, you can see we run pdig, which comes baked into the Falco trace latest image. And we pdig all, and then we just run our init shell script. So anything that is running from this shell script will inherit the pdig, ptrace components of this original process. So we're now able to define how our application starts running with Falco. And in this example, it's extremely simple. There's 4 lines of code here, one of which is just an echo that says running SSH server. So the first thing we do is we run Falco with the -u for user space as the underlying stack implementation. And we have PID file, falco.pid. And then we just do -- daemon, which just forks Falco and runs that in the background as a Linux daemon. The next thing we do is we tail the output so that the output is going to standard out, and we run that in the background as well. The iterator moves forward, we echo out running SSH server, and then we just do user sbin ssh-d for daemon. So we've now effectively created 3 daemons running in our container, everything going to standard out, and we can take this container and we can run this in Fargate. And I'll explain how I was able to set this up in Fargate. And there's documentation here as well if you're interested in hacking on this and getting involved. I went through with way too many cups of coffee and wrote down the process and getting a lot of this working. So here's exactly how I was able to do this that you're about to see today. And remember, this is all running using ptrace, which does have to be enabled in Fargate if you want this to work. So if we go to Fargate, let's take a look at the state of the world as it is today. So in AWS Fargate, we have a cluster here that I call Nova Hacks. And inside of Nova Hacks, we have these things called services. I think of a service as a deployment in Kubernetes, as a stateful set in Kubernetes. This describes your application and how many replicas of your application you would like to run in a containerized environment. In fact, you can even see here the service type is that of replica, which to me, I see replica and instantly I think Kubernetes deployment. So we have 2 containers running. The container image is Falco trace vulnerable and Falco trace SSH. And if we go back here, you can see that we have those described, vulnerable server and SSH here. And so if we drill down into the SSH server, we can go to tasks, which I think of a task as a pod in Kubernetes. This is a single container or set of containers running just like a pod that's running in Fargate in an intentionally isolated environment that now, to the fact that the Linux capability ptrace is opened up in Fargate, we're able to run our runtime security tooling. So what we have here is we have the public IP of our container. Now, as a security-minded engineer, I've only opened up this public IP to my static IP I have here at my house in San Francisco, California. So we can grab this IP address and we can effectively SSH into our container running in Fargate. And so we do that just like this. So we SSH in and we enter our super secret SSH password. And you can see here now, this looks basically like an EC2 instance, but this is a container with access to ptrace running in Fargate. And if you look here, you can see that it is in fact running that Falco command that we looked at in the bash script earlier. It is in fact tailing the Falco logs, and the SSH daemon is running with this pdig command here, as is Falco and everything else. So we can try to do anything we want on the system now. I'm SSH'd in as root. So let's start doing something malicious. Like, let's go and let's create make.dir DevOps in user bin. User bin. Let's do make.dir user bin DevOps. And let's touch user bin DevOps 1. And let's do 2, and let's do 3. So I've come into a system and I've created some what could be potentially executable files in user bin, and we could even go through and create more here. And if you type 1 tab, or anything for that matter, you could go through and you could potentially tab hint and execute these. So generally in an isolated environment, seeing something like this would be concerning, worrisome, particularly if you're running a container that should have already done all of the file system and operating system mutation beforehand anyway. So in this example, and there's hundreds of rules in Falco we could potentially be violating right now, catting out etc shadow, touching directories in /proc/etc, starting an incat server, which we're going to look at in a moment. And Falco will alert when something like this happens. But it doesn't do it by watching user space. It does it by watching the syscalls with ptrace. So if we go back to Fargate and we refresh our page, because everything is running to standard out, all of our Falco logs are now going to AWS Fargate ECS, and we can actually see these in CloudWatch. So we can see error, file below a known binary directory open for writing, user equals root, and command equals touch user bin 1. And if you look at the timestamp, this was just a few moments ago where we were able to make this happen. And just to show you, I will do user bin hey, come back here, refresh the page, click on logs again, and you can see here now we have user bin hey. So you can see that Falco is running and that it's echoing to standard out, and it's just getting picked up in the logs, and it's doing all of this using ptrace. So let's look at another example, which is this vulnerable SSH server, and look at how we can tell a story with this from the AWS dashboard. As DevOps engineers, as SREs, as infrastructure engineers here, we all know the story is what's important. We don't care about the strace logs. We don't care about the kernel logs. We care about being able to say who, what, when, and where. And that is what we need to bring to the conference room after there's an incident or after there's some violation. And we can do that now using Falco in these tools. So in this example, we're going to go back to my Nova Hacks cluster. And we're going to look at the vulnerable server task, or pod if you are thinking Kubernetes. We'll grab this public IP. And in this example, we will use a command called netcat and we will actually build a reverse shell against a small server that's running there that is vulnerable, and we could potentially use to execute commands and do remote command injection against this underlying container. So this is a very common exploit vector for various CVEs that we see from all types of dashboards or executable programs where you could go and run arbitrary code on the back end, but is represented in the UI. This is a well-known issue, and in fact, you've seen this come up in Kubernetes CVE lists time and time again over the past few years. So we need to specify a port. In this case, we happen to be running on port 443, and we run this, and you can see TCP exceeded or succeeded. But what's interesting here is I can list, I can change directory to etc, and while I'm in here, why don't I cat out etc shadow? And there you go. And so now we come back to the Fargate dashboard. We go to our logs, and you can see here, we're actually able to, let me refresh, we're actually able to tell the story of who, what, when, and where when this happened. So you can see that ncat was listening on port 443. You can see the IP address here, and you can see that a file was opened for user root cat command etc shadow, and you can see that I am now able, as an engineer, I am able to go forward and actually tell this story of what is happening in the AWS Fargate using the logs provided from ptrace, Falco, runtime security inside of a container. So all of this was a proof of concept to show that we could do this in Fargate, which is an intentionally isolated environment that now allows ptrace. And my brain had stopped there. I said, okay, cool. We have our Fargate use case. That's what we set out to do. We're done. And this morning I wake up and Lorenzo Fontana, the author of BPF Observability for Linux, had opened up this repository that he wrote yesterday because he was able, oh, what did I do? How do I hate Zoom. Annotate, no. Here, stop share and share screen. And he was able to come in and build this new GitHub repository. I know y'all can't see this, but on my screen, there is Zoom is blocking my mouse from clicking up here right now. So he was able to build this project, which is Falco Inject. And it says this repo exists to show the concept that Falco and PDIG can be injected into running pods. So he took it a step further and said, well, if we can do this in Fargate, let's also do it in Kubernetes. So now using ptrace and Falco, we can attach to a running container. You don't have to mutate the container image. You just can attach to a process in a container and get Falco runtime security given any pod in Kubernetes or any pod in Fargate with the Linux capability enabled. All due to the power of ptrace running underneath the hoods and our ability to use ptrace as an avenue to consume kernel metrics. So that's it. That's my presentation. That's ptrace, that's Kubernetes, that's Falco. I'm here if folks have questions, and I'm going to stay here on my my screen here until I either hear somebody from DevOps Days cut me off, or I see that I've been cut off, or if somebody messages me on Twitter, so I know kind of next steps of what to expect. That would be helpful. And otherwise, follow me on Twitter. Ask in the Falco Slack. I'm on GitHub. Twitter, it's github.com, or sorry, my GitHub is github.com/Kris Nóva. My Twitter is twitter.com/Kris Nóva without the hyphen. If you're interested in getting in touch, or if you have questions afterwards, we're happy to help. And if you're interested in seeing a demo of any of this moving forward, please feel free to reach out to us. We're happy to share the open source code. And if you would like to get involved with the open source code, please do feel welcome to come and join the Falco GitHub at github.com/Falco security. And you can find out more about us there and the work that we're doing. So Yebian says, thanks for a fantastic introduction to ptrace. Very interesting, very accessible. Leon Kens says, great presentation. So I'm reading from the twitch.tv. Here, I'll actually add this here. I'm reading from twitch.tv/setns right now. if folks need to get a hold of me.
Hey, Kris,
and
thanks for the presentation.
Oh,
Do you hear me well?
yes, I can.
Yes.
There
Yes,
you
you can. I am the moderator. Yeah, so
Hi.
it was a really, really great presentation. Thank you for that. Thank you for that. We don't have much time, and we have a huge amount of questions. So I had some jokes about how I was trying to use ptrace back in the days when I had to run Windows game on Linux with Wine emulator, but I'll just leave them alone. So let's start with questions. So the first question, the most rated one, Volodymyr Tsap asks, does Falco plan to support WebAssembly for plugins like Envoy?
Does Falco plan to support WebAssembly for plugins
Yes.
like Envoy? So it's been brought up in the past. I would say that, to my knowledge, there's no one actively driving this, but I know that myself and all of the other maintainers are deeply interested in having some avenue here to support Envoy and the Envoy proxy. And there's been other use cases brought up in Falco to use Envoy as well, particularly when it comes time to managing Falco instances across a cluster and amalgamating the output of those instances and proxying those to a single endpoint. So right now, not to my knowledge, is anybody working on it. Would we love to see it there? Heck yes. Would we love for you to get involved? Heck yes. So that's where the Falco project is today.
Great. So the next question: what happens if the malicious actor kills the tail -f on the Falco process?
So again, this is all running at runtime, and the idea here is that if the malicious hacker could kill that process, they would effectively be blocking the avenue in which we're receiving events from the kernel, which was the whole inspiration for doing the kernel module approach in the first place. But anytime there's a malicious hacker, the idea is that it's a matter of time before they discover what they would potentially need to do to cover up their tracks. And the goal here is for Falco to be fast enough and for your infrastructure to be described in such a way that it is diverse enough to where if a user exposes infrastructure A, that is recorded and reported in a different place so that you could still tell that story moving forward. So in order for me to even access this maliciously, I would then have to first expose my IP and the original command that then would be recorded and sent out elsewhere. And we see the same problem with the kernel module. If you were running Falco or any security tool in Linux, other than some of the ones that are built into the kernel, you could restart the machine, I guess, but you still run into this problem that a user could potentially get to root. And once they get to root, they would be able to escalate horizontally and take action. So the philosophy here is that in a world like Kubernetes, in a world like Fargate, these logs would go to CloudWatch, and that infrastructure exists completely independently. And then you can use the CloudWatch story to understand what happened. So that's the solution, or the prescribed path there, is just having basically a diversified portfolio of infrastructure.
Yeah, actually, it does make sense. So if someone takes your machine over, there is nothing you can do. I mean, it looks like the game in the old days when a couple of friends log into the same server and try to disconnect one another from that, and try doing things like that. So yeah, it's all about notifying first, and then then doing something on those things. So the next question is, what sysdig would sell on top of Falco? Security rules, consulting, UI, etc.?
Great question. So we have a number of commercial products. We have Sysdig Secure, we have Sysdig Monitor, and we have Sysdig Platform. Sysdig Platform is just the combination of the first two. And I would say look at Sysdig. Sysdig is to Falco as a cloud provider is to Kubernetes. We have a lot of professionals. We're the original authors of a lot of the software. So you're talking to the domain experts, the knowledge experts. Literally the person who wrote the code I just demoed is the CTO of our company. And hopefully he's watching right now. Hi, Loris, if you're watching. And we offer everything from rule management to tuning to policy to observability. We have an entire platform built around Falco, and we like to consider ourselves the enterprise Falco solution.
Okay, so the next question is, do you know if someone actually tried using Falco in actual security audits like SOC 2 and HIPAA?
I'm sorry, like what, security audits like what?
Like SOC 2 and HIPAA? Those are paperwork.
SOC 2 and HIPAA.
Yes.
Yes. Okay, so the answer is yes. We have people who are doing, we have a use case that if you are going to be at KubeCon remote, I don't want to spoil the fun now, but we have a very exciting keynote at KubeCon where we're going to be talking about a production use case where somebody's running Falco in a PCI compliant environment and uses it in production. And we've had other users who report it for HIPAA compliancy, SOC 2 compliancy, and so on and so forth. And it's a fundamental part of their stack. And the security industry is interesting because we have people who share this with us under NDA, but it's really hard to get people to publicly talk about the tools they use to secure their systems, believe it or not. So yes, we've seen people who have done this. Yes, there's examples out there. If you want concrete examples or if you want to get in touch with them, reach out to me. We have a private GPG encrypted maintainers mailing list where we do a lot of those types of transactions, and we can get an NDA with my company if needed. So yeah, we would love to hear more about it, but we do take security as a top priority here.
Okay, so the next question, very interesting. Nothing is clear. Can you recommend where to start implementing? You can start from this presentation.
Very interesting. Nothing is. I'm sorry?
I was trying to answer. So whoever asked this question, you can start from this presentation.
Yes. And I guess to take a stab at answering that as well, if you want to run an application in Fargate and you would like to have a set of checks and balances and have something watching that application, that would be your use case. So I would say anybody who's running anything in Fargate or Kubernetes could potentially be interested in what I just demonstrated here.
Okay, thanks. So the next question is, what is the recommended tool for integration with Falco for receiving alerts? Well, as we have just seen CloudWatch, but maybe some other.
Yeah, so if you look at Falco, so again, Falco is the open source component. And my company takes this a step further, and we have built, we've spent a lot of time building out a lot of integrations for this output mechanism ourselves. But what we have here in open source is if we go to the Falco repository, and again, I'm sorry, Zoom is going to prevent me from clicking up here right now. But, oh, we're not doing a screen share. But if you go to the Falco repository, there's, go ahead.
We do.
No.
We have a screen.
Oh, okay, great. So I have it pulled up on my end, but if you go to the Falco security GitHub org, there's a Go SDK, there's a Python SDK. There's been talk of writing one in Ruby. I think there's one for, there is one for Rust. We can go to standard out, we can call a webhook. We see folks have contributed a number of different integrations. There's the Falco exporter, which was written by Leonardo Grasso, one of the maintainers and Sysdig employees. And he was able to write a tool called the Falco exporter. And the Falco exporter basically connects this up to Prometheus for you. We also have the Falco Sidekick, which was donated by a really, really awesome guy based in France outside of Sysdig. And that connects it to, there's a whole list of different integrations we have there. Let's look at the Falco Sidekick. It might have been renamed in here, but let's look for Falco and see if it's here. Falco Sidekick, here it is. You can see all of the different integrations we have here. Slack, Teams, Datadog, Alert Manager, Elasticsearch, Loki, Nats, InfluxDB, AWS Lambda, SNTP, OpsGenie. There's a lot of ways you can connect to it here. So the Falco project aims at building the community around how you would consume these and what you would connect them to. And then the IP is then built on the actual implementation of how you would do that and what your prescription is. Just like how Kubernetes says, here's our APIs and how you can run things on Kubernetes, but we're not going to tell you what it is you want to run. That's up to you and your architectural team to decide. So Falco is the place where we just are building the communities and building these projects out. And there's a ton of work for the Falco outputs going on right now.
Okay. I wanted to end this up here, but we have a very interesting question. Do you have information about pgig/Falco impact on application/cluster performance?
So yeah, and you can cut back over to my face if you want. So we have some benchmarks. I took a stab at writing one, and I'm not a benchmarking expert, but we have some others that are in the mix right now. And if you go to the pdig repository, there's a section on the speed of ptrace, which if you look at the way ptrace works, particularly around ptrace stops, there's a lot of redundancy that's going back and forth between ptrace and the underlying kernel, and then with your application, and there's hooks and places for you to hook in and stop and start. So there is some overhead at the computational cycle. If you're looking for an exact number, I would suggest just doing an A/B test between running computational workload with and without pdig, and then you can get the delta there, and you can start looking at the overhead there. We have been giving this a lot of thought. I don't want to say too much right now, but if performance like that is a concern to you, we should definitely talk. You should definitely reach out to me, and we can talk more at that time.
Okay. Thank you, Kris. That was a really, really good talk and really great Q&A session. I hope to see you sometime in Kyiv on the offline event, on the real event where we can see the audience. But that's it for today, and we are moving to the closing speech. So again, thanks for watching. The feedback form for all of the event will be posted into comment section. By the way, please take a look into the video description. We have a promo code for an offline event, which, as we really want to do this early in September. We don't know if it's going to happen, but anyway, it's 30% off just for you. So please go ahead and take a look. Again, plans for tomorrow, at the same time, we will have a second day and two speakers, Neil Murphy and Liz von Jones. And that all is going to be moderated by Daniel Marr. So we will send the link to the translation later, as we did today, maybe like a few hours before the translation. So please join, and please go to the Zoom video rooms for the after party. And DevOps Day team hopes you have enjoyed this video program. Please like and subscribe. And that's it.